Hey guys, welcome to this video. My name is Rafi and today we are going to address one of the challenges. We don't want to say the most important challenges when we use ArgoCD as our deployment management tool. So without any further ado, let's get into it. So what exact challenge are we talking about here? Considering the philosophy of the Git apps and working with ArgoCD, we basically need to have everything, definition of everything inside Git. And ArgoCD is responsible to just add Kubernetes objects based on their definition available in Git. This is how actually ArgoCD can track any changes, any drift in the changes in different environments. So does that mean actually we should put sensitive data, like the data we want to keep it as a secret in Kubernetes, or some other sensitive data that we want to keep it in config maps and so on and so forth, in Git? Is the good approach to go with? I would say no. This is not the best approach to go with, of course. And the reason is like, you may provide access to the Git to too many different people, right? I'm quite sure that you don't want all of them to have access to those sensitive data. So that's the basic and main reason that why we should not put sensitive data into the Git repositories. Then what can we do to address this issue, by the way? Because if we don't want to put this kind of information in Git, then how exactly ArgoCD is supposed to act upon that? How exactly ArgoCD is supposed to create the secret objects? To address this issue, basically we need to use some other third-party components, including like SOAPs, KMS, like Vault, or whatever. It doesn't really matter. But the point is, Vault is actually one of the most popular and secure tools out there. So we are trying to address this issue using Vault ArgoCD integration. Let's see how exactly can we do that. So before everything else, we actually start working with a very clean environment, right? All the configuration, all the code is already pushed to the Git repository, and the link for that Git repository can actually be found under the video. But the point is, like, for the sake of the learning, we shall do everything again together right now. So the first thing, we actually need to have ArgoCD installed. And for that, we have to have a Kubernetes cluster up and running. For bringing up the Kubernetes cluster in our test environment, I personally, again, tend to, most of the time, use Kind tool. And the reason is like Kind is super lightweight, it's flexible, it provides you with most of the features of the Kubernetes, and working with it is actually super simple. So let's see how exactly can we bring up a cluster using Kind. Here I'm gonna just create another, or let's say our first file. I would call it as, let's make it correct way. So I would say I would go with infrastructure, right? And inside infrastructure, I will hold the configuration of the kind for both cluster Vault and ArgoCD. But first, let's bring one for ArgoCD. So I would say argocd.yam. The configuration of the cluster is actually a YAM in a YAM format. So if we go to the configuration here, it's actually quite simple to go through, nothing specific. The kind is cluster, and then the networking. I mean, here is the most important part, which you should actually just set it with your IP address, whatever it is. Let me check mine. And there it is. So this is my IP address. Basically, this is gonna be the API server address for the Kubernetes API. So whenever we want to deal with the Kubernetes API, like whenever we want to use kubectl command, kubectl should be able to communicate with this address in this port. I would change this port to 6. And then the rest is actually nothing specific. Another important part here is just like the number of the workers and control plane you want to bring on. I would continue with one control plane and only one worker. So Having that in place, we can simply create a cluster using create cluster. So actually the command is create cluster. The name of the Kubernetes cluster you want to bring on, which in our case this is Argo, and then the config file, right? The config file is right here, and we just name it as, let's say, ArgoCD yum. So by running this command, we expect kind to be engaged, to be invoked, and start bringing up the cluster based on the configuration we provide for it. So let's see. Cool. If I run kget nodes, I shall see one control plane node and one worker just based on the configuration. We shall create another file for Vault cluster here. I will just copy and paste this one, but two things should be changed. First, this port is actually reserved, so I will just change it to 7443, and the rest can be just the same. So I would again create cluster, but this time lab-vault with the config file that can be found here. So yeah, everything looks good. I will hit enter. And then, okay, both clusters are up and running. If I check the clusters I have using kubectx command, I shall see Vault here and Argo here as well. Cool. Now that we have the Kubernetes cluster up and running, it's time to install ArgoCD. So unfortunately, the installation of the ArgoCD is actually a manual type of action. It's just like chicken and egg, right? ArgoCD itself is responsible to deploy everything in our clusters, right? But who exactly is responsible to install ArgoCD? In that case, we are going to use Helm for installing the ArgoCD. That way, we can actually have the flexibility to change the configuration on demand or on the fly and so on and so forth. So we will leverage Helm for that. Let's see how exactly can we just install it, Kubernetes cluster. I will switch the context to lab-argocd. I don't have anything and anything which is desired and expected. So installing the ArgoCD using Helm is super simple. You can find the documentation in the official documentation of installation ArgoCD using Helm. Basically, only two commands is required. First command is responsible to add the Helm to your local Helm repository, and the second is actually responsible to install it. So let's get through it. I would say Helm repo add, and this is basically the URL for the for adding the ArgoCD to the local repo. And then we also need to have it updated, Helm repo update. And then install ArgoCD, and here, of course, do it in the namespace ArgoCD. Yeah, okay, create. And then, so the error we just faced with is basically originated from the fact that the namespace ArgoCD is not created yet. So I will create it, ArgoCD, and install it via Helm again. And let's see what do we have here. So if I check the overview, there should be ArgoCD, something is happening, something is pending. Okay, let's see what's going on. Still downloading things. Cool. Apparently we have ArgoCD installed in this Kubernetes cluster. Let's make sure. Yeah, I see more things here. The pods are coming up one after another. Cool. Now that we have everything up and running, most specifically the ArgoCD server deployment, the next step to access the ArgoCD is actually creating a binding between its service port and the local port. That way we are actually able to access to ArgoCD UI. Let's make it together. I will bring up a shell here, and I would say let's go to get PO and get SVC. Amazing. So basically I have the service created. Now I need to forward the port using kubectl port forward. Let's do it together. So the service name is actually ArgoCD, and the namespace is ArgoCD itself. And I want to expose my local port in all interfaces. So I would use --address 0000, and I would like to have, let's say, port 8080 to 443 HTTPS port of the service. Let's make it, and then let's see. So yeah, and then start. Okay, cool. Cool. The first time I would accept the risk. Of course, we didn't set this certificate and the TLS for this specific domain. We should get this error. For the login part. Yeah, so the username is always admin for the initial created account, I would say. But how are we supposed to get the password? So if you check the output of the Helm install, actually it's also mentioned here. So basically with this specific command, you can get it. The way that it acts is actually after first initialization, ArgoCD will create a secret with the name of ArgoCD initial admin secret. And the value of this secret, I mean in the data password, is actually the initial password for it. So let's run it and copy this one, switch back to Argo, and there you go. Okay, perfect. So we have the ArgoCD installed and up and running in Kubernetes cluster. So now that we have ArgoCD up and running, basically ArgoCD should be responsible to install any other application in any other Kubernetes cluster. Doesn't really matter, right? Whatever is responsible and whatever is supposed to be in our system should be deployed by ArgoCD. So that means Vault itself should also be installed via ArgoCD. To address that requirement, the first step is to add it to a specific repository. Let's see how exactly could we do that. So in ArgoCD UI, we can do that via CLI as well. We can do that. I would say let's go with this UI feature, and then we have to go to the repositories, and inside the repository we want to connect it to a specific repository. The repository I want ArgoCD in our test environment to be connected to is actually an open, let's say, Git repository. So basically, any kind of authentication is not required. I would just set it as HTTPS, and the project is a default project. The repository gonna be this one, with or without .git at the end, and yeah, that should work. So basically, this repository is the repository that you can find all the codes that we are trying to implement right now together. Actually, there in the main branch. But yeah, we will get into it very soon. Just wanted to mention it here once. And then by hitting connect, I should see the status as a successful. We have no problem with it. Amazing. So what should we do next? Going back here to the code, and then I would say we already created a directory, namely infrastructure. I would say we need to also create a directory, namely applications. And application is basically the directory that holds all other ArgoCD applications. So whatever is supposed to be deployed in our Kubernetes clusters, right, should be placed there, because all of them going to be an application. And the pattern we are going to just use ArgoCD application is the pattern of application inside application. So basically, just for a review in ArgoCD, you can just add a specific path or repository and a specific path in that repository. And then ArgoCD will iterate through it and find all the YAML files and then just deploy it wherever it's supposed to be deployed, right? But there should be an application for it. So there is a root application that already defined that how exactly should you deal with this kind of YAML files, where exactly should you deploy them, and so on and so forth, right? The method we are going to do is just like creating a root application, which is responsible to iterate through a specific directory and find all the file and folders. And then each of those folders actually gonna hold another ArgoCD application, which defines exactly where this specific application should be deployed. In our case, for example, Vault is not supposed to be installed in the same Kubernetes cluster that ArgoCD is in. It's actually supposed to be reinstalled to its own dedicated cluster. And the way that we do it is actually by defining an application inside the application. And in the inner application, we will define the destination for Vault. So let's get through it and see it in action. And I mean, that makes more sense then. Let's see. I will create another directory, definitely not under infrastructure, but let's say mkdir command applications, cool. And inside the application, let's get another directory. Let's create another directory, namely Vault. Come on. Namely Vault. And so far, so good. And in that, actually, I will create I will create the definition of the application, right? And then I will call it like application-vault. Naming really doesn't matter. And then I would also, yeah, the point is here now. I will create the vault using Helm, right? So basically, ArgoCD gonna be responsible to install Vault using Helm packages, right? And because we are using Helm, we can basically also have a values file to make it customized. Of course, the version of the configuration of the Vault that we are going to deploy is the simplest one. It's the original one. It has nothing to do with the, high availability, TLS configuration, the backends, and so on and so forth, because this is not the subject of this video. But either way, actually, it's a very good practice to have another values file side by this application and then refer it to the application. We shall see it together, but keep in mind that way you are more flexible. I would also create another values.yaml file and keep it empty. I will keep it empty because I wanted to go with the default configuration. Let's create the application vault.yaml. We shall have the ArgoCD application here. I would go through each of these sections. I mean, for those people that are not that much familiar with the ArgoCD applications, I will try to just give you a view. I mean, a very broad view, but at least, I mean, that makes more sense to you as well. So ArgoCD application is another YAML file, basically. Define this application. Each application comes with name and the namespace, right? The application itself should be in the same namespace that ArgoCD resides. Keep it in mind, because if you want to install it in another namespace, basically you will face with an error that says that I don't have enough permission to do that. And the reason is just like the ArgoCD application should always be inside the namespace that ArgoCD lives in. Keep that in mind. And then we have a spec and the destination. So in the destination, I will set kind-lab-vault, right? Because I want Vault to be installed in its own dedicated Kubernetes cluster. And the namespace is going to be Vault, and the project is default. That's okay. What sources do we have to be installed in this application, right? So I hope you grasp the idea. I mean, this is like the ArgoCD application. It's just like a wrapper, or not like a wrapper. It's just like a manual that says ArgoCD what exactly you should deploy, where to deploy, with which configuration, right? This part till here, right, was only for definition of the application itself, the naming, the metadata, the namespace, and so on and so forth. But the real important part is here, the sources, right? For the sources, we will add the Helm repository for Vault. We will install chart Vault out of it, right? And as it is Helm, we can define our custom, let's say, values file here. Remember, I told you that we will keep these value files even as empty, but we will keep it because later we might need to just add some changes on it, right? And if we have these value files here, it's going to be as simple as just adding new values here, and ArgoCD itself will take care of the adjustment and redeployment and whatever that is actually supposed to happen in the target cluster. So in the values file, we use the values reference, and then it's not, and then we have to provide it with a path. So the path is actually application, and inside the application, or applications, and inside the applications, we're gonna have Vault, and inside Vault, we're gonna have values.yaml. Super cool. And then, and where exactly these references actually coming from? The reference is defined here, right? So I just give it here, give the repository address here, the target region. So the point is, like, I don't want to go with the head actually, because I have my own branch here. So the branch that you have to check is actually this branch, and then whatever is inside this directory should be referenced as values, right? And here we use the reference of values using this $sign and so on and so forth. And the sync policy, I mean, nothing specific. It should be automated or self-filter and so on and so forth. It's all good. So far, so good. I have the definition of the application. I went through the path of the application inside the application, and yeah. But should it really work? Of course not. Because this is the key part here. We set destination to kind lab vault, which is the name of the other Kubernetes cluster. At the moment, ArgoCD doesn't know this cluster at all. So it's not even have enough permission to, just manage deployments there and so on and so forth. So the first thing before trying to have Vault applied is only by, let's say, adding the cluster, right? Let's go through it. The way that we are trying to add the cluster is going to be like using ArgoCD CLI. Let's say ArgoCD login, and then this port. So basically, this is the address that ArgoCD UI is actually accessible. And then I shall say the username gonna be admin. But what about the password? I forgot the password. So get secret, I have this initial, so get secret, this one, -yam. So this is the base 64 of the password, echo this one by base 64-d. So this is the password. So I will just enter it here and logged in successfully. Okay. How to add the cluster? ArgoCD cluster add, and then the name of the cluster you want to add. Remember, this is the same name that already set in your config file of the kubectl. right? So all the credentials, whatever is required to, just access or gain access to that cluster is already inside your config file of the kubectl. So this is the way actually that ArgoCD CLI as well can authenticate and do the rest. I will go through it, and I hope everything goes okay. Amazing. So basically the cluster added, and this is the IP address of the Kubernetes API for the other cluster. Very good. Now that we have everything in place, I can push the changes. Okay, cool. So far we have everything in the Git repository and the corresponding branch as well. The only remaining part is going back to the ArgoCD and create the root application. I will call it as applications. The project, of course, is a default one. Let's say automatic. And auto create namespace, of course. I don't want to all the time create a namespace myself. Which revision? I would say Argo Vault integration. If I'm not mistaken, this was the branch. And what paths exactly? So let's see the paths here. So in paths, I have applications, and whatever inside the application is supposed to be deployed by ArgoCD. So I would say only applications. That's it. And the destination. Remember, this is the destination of this ArgoCD application. So it should be in the same cluster and the same namespace of the ArgoCD, and we don't have to do anything for the rest of it. I would say I would keep the directory recurse. Yeah, I will keep it directory recurse as true. And let's see. We have application created. Inside that application, we have Vault. If we go to the Vault, cool. We shall see all these things are being created in Vault cluster, right? And then how can I make sure? I mean, I'm quite sure, but again, let's check it. Lab Vault. Go to overview and check the namespace Vault. Cool. Deployments. I have deployments here, right? Amazing. So far, so good. So if we go back to the ArgoCD Vault application here, like this, and then you shall see actually the Vault pod itself would never get healthy. And there's a reason for that. Basically, this is how Vault works. So in the first initialization of the Vault is not coming up with a functional status. It's called sealed. So basically, in the first initialization of the Vault is sealed, and we have to unseal it manually or automated. Well, it doesn't really matter. But for time being, we will just go through it manually. Let's also check the logs here if we have any. So webhook, certs, and so on and so forth. So in order to unseal Vault, we have to run certificate commands in the Vault pod. So let's change the context to kind-lab-vault. Okay, get PO kubeNS vault, and again, cool. So if we go here, okay, exec-it here, and get the bash, doesn't have bash, get the shell. I will just increase the font size. So yeah, so what we should do here is just like Vault operator init. And what it does exactly, you have to refer, of course, to the Vault documentation itself, but here we don't want to dig it that much, but the process is just like this. In the first initialization of the Vault, you have to run it. It will provide you with 5 Shamir keys that you should keep somewhere safe, because from the moment that Vault is initialized on, whenever it gets sealed again for unsealing, you will need those keys. And also they provide you with one root token, and that root token is being used for connecting to the vault in the first time when you don't have any kind of user-defined vault. So let's see, vaults init, it will provide 5 keys, right, along with one initial token, one root token, let's say. Now that we have this case, it's time to unseal vault, right? So again, the command used for unsealing process is like vault operator unseal. Cool. And it asks for one of so basically 3 out of 5 keys should be provided for unsealing process. I just hit it 1, it's accepted, but still the status is sealed. So let's go with the second. And this is the second, and still the status is sealed, but we have 2 out of 3 keys accepted. And let's go for the third one. So this is the third one. After entering the third one, you shall see that the sealed status is actually false, which is good. And if you go back to the ArgoCD again, we shall see the vault healthy. Amazing. So far we managed to install Vault by ArgoCD.